In this video, we're going to simply calculate the period of these other functions, secant, cosecant, tangent, and cotangent. And it's pretty straightforward and very similar to the last one. So this video will take a little bit less time, but I do need to introduce a few ideas. First, you'll notice that I'm not asking you for the amplitude. And that's because when we're talking about sine and cosine, they have a top and a bottom. So amplitude, the idea of an amplitude here, makes sense in terms of sine cosine. If you look at all these other ones, we can't talk about their amplitude in the same way. We could talk about the distance between the bottom of and the top of the secant and cosecant and maybe talk about that in amplitude, and it actually is related to that, as we'll see later. But it's not the word that we use. And tangent, cotangent, we definitely don't use that word there. So, and again, amplitude is related to their shape, but it's just not something that we're going to focus on. So we're not going to talk about the amplitude of these shapes. Now, what we are going to talk about is their period. And they actually have two different sets of formulas. The formula that we had before was dependent on this sort of generic form. Y equals a sine of b x or theta. And I'm going to use theta now in the videos moving forward. I'm going to use theta because that's the common variable used for an angle. Okay, now I told you that sine could be replaced with tangent, cotangent, secant, cosecant, and it can be. But what's different is that in the period formula will vary just a bit depending on which one it is. So for sine and cosine, and for secant and cosecant, the formula is the same. It is 2 pi over b. But as we saw in the last video, tangent and cotangent repeat themselves twice as frequently, so their period is half as long. In other words, their formula is just pi divided by b. So for secant, cosecant, sine, and cosine, we have the same formula as last time. For tangent and cotangent, it is different just by not having the two on top. And that's it. So let's go ahead and use these formulas. I'm going to erase them here, so hopefully you memorize them. And we'll go ahead and use them to solve these ones. So here we go. Okay, first let's identify what b is. In this case, b is 2. When we're dividing is like multiplying by the reciprocal. So in the case of tangent of theta over 4, b ends up being 1/4 because multiplying by 1/4 is the same as dividing by 4. Okay, down here we have b is equal to 5. And then lastly, down here we have b is equal to 4/7. Because 4/7 times theta, that theta can sort of move up to the top with the 4, so that's one way of expressing it. So there you go. There's where b is. Now we got to go ahead and do this formula. So whenever I see secant, cosecant, sine, or cosine, I'm going to do 2 pi over b, and wherever I see tangent, cotangent, just 1 pi over b. Here we go. Okay, I see cosecant, so I'm going to do 2 pi. Over b here is 2, which is just equal to pi. There we go. That's it. Over here I have tangent. So I'm going to do pi divided by 1/4. And pi divided by 1/4 is the same as pi times the reciprocal of that, or just times 4. So this is equal to 4 pi. There we go. So there's the one for tangent. All right, now we do it for secant. Again, it is 2 pi for secant. Divided by, well, b here is 5. I can't reduce that, so I'm done. Okay, and then down here we have cotangent, and cotangent is just pi divided by 4/7. And once again, when we divide by a fraction, that is the same as multiplying by the reciprocal. And so we get 7/4 pi, or 7 pi over 4. And that's how we would express it. Okay, there you go. This video is the shortest of the 3 this week, but that's how you find the period of one of these functions.